In this video, we're going to learn how to write rules for patterns in two different forms. The first is called the recursive form. The second is called the explicit form. Now, there are certain advantages to both. For the recursive form, it's based on previous numbers in the pattern. Okay? It's also frequently easier to find. And we call it a now next rule. That's how we're going to refer to it in this video and in class. Okay? So, in these now next rules, okay, like I said, it's often simpler, and it's because we use the terms around it. So it's helpful when finding a few nearby terms. So if we have the first 5 terms, it's going to be helpful to find the 6th or 7th or 8th, but maybe not so much the 88th. Okay? So only the ones close by. And there's 2 parts to this rule. The first is the start number. Okay? And then the second is whatever we have to do to the now number to get to the next. Now, we're going to see this written in a couple different ways. The start number, okay, we're going to refer to as a sub 1. Okay? So we're going to say a sub 1 equals some number, and then we're going to say now plus or now minus some number equals the next number in the list. Okay? We might even have the next equals next on a different side. Okay? Now, if we're multiplying in the pattern, of course, it could be multiplying, but we are almost never going to divide. Okay? We might multiply by a fraction. So, here are a few examples for us. Okay? In the first example, okay, I have a pattern that goes 4, -10, -16. Okay? So my starting number, or my a sub 1, is a equals -4. And then the pattern is each time I'm subtracting 6. So my rule is going to say next equals now minus 6. Okay? That's all there is to it. So in my next example, I have a list that goes 2, then 6, and then 18. Okay? So the first number here is 2, so a sub 1 is 2. That's the starting number. And then the rule is next equals now, and then to get the next number, you have to multiply by 3, so now times 3. It is very straightforward in that manner. Now, these rules are helpful if you're finding like the next term or the next couple terms. But when it is, a number way down in the list, that's not so helpful. That's why we use the explicit rules. The explicit rules are helpful because if I want to find the 50th number in the list, or a sub 50, all I have to do is plug 50 into the formula, and we go from there. So here are the rules for writing an explicit rule. First of all, it's based on a term number or a counter. Okay? Meaning like the position in the list. And we're going to use X or N for those placeholders. Now, if we're adding or subtracting the same number, okay, every time, okay, then we have what we call a constant rate of change. That rate of change I'm going to refer to as ROC. Okay, so here is an example. Okay, I have some table with some numbers in it, and this case goes 1, 2, 3, 4, or if we're just talking about positions, a sub 1, a sub 2, a sub 3, a sub 4. All this stands for is a position in the list. It's not the actual number in the list, okay? that number is going to be over here. So if I would ask for a sub 2, you would provide this number over here. Okay, so let's give you some more specifics here. So the first thing we have to do is find the rate of change, okay, per term number. Okay, it may not make sense in this particular instance, but it will here in just a moment. The second step is we're going to write a simpler rule, and it's y equals the ROC times x. But then we have to test it. All right? And basically all you do is you take the position times the ROC, and we're going to write it here in the middle. Okay? And that's going to tell us what adjustment needs to be made to that number. What do we need to add or subtract to get the final number over here? And that is step 4. Add or subtract some number to give you that final value. Okay, so here are a few examples. Okay, these go 1, 2, 3, 4, 1, 5, 9, 13. Okay, on the left-hand side, each of these are going up by 1. So I'm denoting it as plus 1. Over here, these are going up by 4. So plus 4, plus 4, plus 4. Those are all the same, so I can write an explicit rule relatively easily using these steps. So the first thing I'm going to do is I'm going to take right over left. So that's 4 divided by 1, or just 4. So I know my rule is going to look like this. Okay, rate of change times x. Okay, now I have to find out if there's some adjustment. So I need to test it. So I'm going to do 4 times 1 is 4. And what do I have to do to 4 to get to 1? What do I have to add? Or what do I have to subtract? Well, to go from 4 to 1, I have to subtract 3. Okay, so let's see if subtract 3 is the adjustment that's needed on the second line. 4 times 2 is 8. Okay, ask yourself, what do you have to do to 8 to get to 5? And it's subtract 3. So, because it's subtract 3, I know I can write minus 3 because both of these are the same as far as their adjustments go. So now, let's just say I want to find the 5th number in the list. Okay, so I want to find a sub 5. So that just means I'm going to put 5 in place of x. So 4 times 5 minus 3. And that is 17. Okay, so that's the 5th number in the list, or a sub 5. Okay, here's one that's a little bit more complicated. Okay, in this problem, the left side is going up by 2. And over here on the right, we're going up by 6. Okay, so we go 2, 4, 6, 8, 10, 16, 22, 28. So my rate of change is 6 over 2, or 3. Okay, so that's what I know so far. So now I have to test this out. 3 times 2 is 6. Okay, what do I have to add to 6 to get to 10? I have to add 4. Okay, so 6 plus 4 gives me 10. So I think I have to add 4. So let's test one more. 3 times 4 is 12. It takes 4 more to get to 16, so my adjustment is plus 4. All right, now if I wanted to, I could test it out again. 3 times 6 is 18. 18 plus 4 does give me 22. So I'm correct there. Now if I want to find the fifth number in the list, okay, if I want to find a sub 5, okay, I'm just going to put 5 in for 3. Sorry, put 5 in for x. 3 times 5 is 15, plus 4 is 19. Okay, so there you have it, folks. Those are all the notes you need to be able to write explicit rules and now next rules. Now, if one of our patterns does not fit one of these, as far as adding the same number, okay, on both sides, like this, so meaning straight down these are the same, then we can't use these rules to write the explicit rule. We might have to change something, and we'll talk about that at another time. Otherwise, thank you very much. If you have any questions, feel free to ask. Have a good day.